Okay, today is our second day in parametrics, and to look at curves defined by parametric equations. All right, so let's look at this curve right here that I've got. When I look at it in parametric equations, and we're going to be drawing these today, you're going to notice that these arrows, and you're going to see where the arrows come from. You've got x and y, and so each point that's x and y is represented by two different functions, f of t, g of t. All right. Now, we can't describe the curve C by an equation in the form of just like y equals f of x. Because if you look, say, example of this graph, it fails the vertical line test. If I were to draw a vertical line at certain points, it touches more than one point at a time. So that's why it fails the vertical line test. But we can think of the x and y coordinate of the particles as separate functions themselves. So each point x, y, we would have like f of t, g of t, and these would be two different functions. And these are known as parameters or parametric equations. All right. As t varies, we can trace the curve. We can also write an equation for C. So that's what you're going to see us do today. We're going to write some parametric equations. All right, so here we go. Get your pencils ready. All right, the first one we're going to look at and we're going to draw is that we're going to look at number one. Okay, let's say x equals t squared minus 2t, and then y equals t plus 1. All right, so let's just draw this. Now, we don't really have any, what was it, like anywhere where we need to start. I'm just going to start it at t values of, let's say, -2, and we could do more than this if we want. -1, 0, 1, 2, 3. We've got some negatives in there, positives in there as well. All right, and we're going to find the x and we're going to find the y. And basically, it's plugging in each of these t values into each of these. All right, so if I plug in -2, all right, and I'm just going to do this very quickly. That's going to be 8. Now, if I plug in -1 in there, I get 3. If I plug in 0, I get 0. If I plug in +1, I get -1. If I plug in +2 into x, I get 0. And then if I plug in 3 and for t, I get 3. And now we would do the same thing for y, like -2 times or +1 is -1, -1 plus 1 is 0. 0 plus 1 is 1, 1 plus 1 is 2, 2 plus 1 is 3, and 3 plus 1 is 4. All right, and now I graph these XY coordinates. All right, and just kind of look. As far as my x, it goes up to 8. 1, 2, 3, 4, 5, 6, 7, 8. If you have graph paper, it actually might be better to do 3, 4, 5, 6, because then it would be actually spaced out evenly. All right, so let's look. 8, -1. Now, the key is to actually go in order here, from the smaller t to the greater t, and I'll show you why in just a second. So when t equals -1, the point is 3, 0. All right, which is going to be right here. Okay, and then at 0, I'm going to 0, 1. When t equals 1, it's -1. Oops, -1, 2. All right, then it's 0, 3. Okay, and then 3, 4. All right, like this. And this is all I have graphed for right now. Okay, so it's going something like this. And what I'm going to do is I'm going to put the arrows on it. I'm going this direction, okay, because I started with a value of t that started out -2, then I went to -1, then I went to 0. All right, and I'm doing it in the order of the t values that are given to me. All right, now, say I want to write an equation for this thing that is not a function. All right, it looks like a sideways parabola. All right, so here, the first thing we want to do is we want to eliminate parameters to write the equations for the equation for the curve. All right, so here, we want to take one of these. We got x equals t squared minus 2t, y equals t plus 1. In one of them, does it look easier to solve for t in one of them? And it does. Like this one right here, it looks easier to solve for t. If I did y minus 1, I get t. All right, so you want to solve for t in one of these. All right, so solve for t, and I did. Now what we're going to do is we're going to take, since we know what t equals, we can take it and put it into here. So now we're actually writing it in terms of, instead of having x, in terms of y right here. Now, if we want to multiply this out, we can. This is going to be y squared minus 2y plus 1, negative 2y plus 2. All right, so here x equals y squared minus 4y plus 3. And if you recognize this, this is actually a sideways parabola. We can see if we can graph this right here. So let's actually go and look at Desmos for this. Let's see if it will actually pop up. And you could actually, you can put in the original one like this before we actually multiplied it. Minus 2 and then y minus 1. All right, and if we actually look at this, we see that this is the parabola for it. Okay, we can try to write this x equal, or like x of, oops, t equals, all right, t squared minus 2t, oops, and then y of t equals t plus 1. I don't know if that gives us, no, we can't do it that way. I was thinking that maybe we could graph each one of these individually, but it doesn't work for us. All right, but isn't this right here the graph kind of like, and you can see these points. I've had that point plotted, had that point, and that point plotted. All right. Now, if you do have a TI-84, I do know we can change this to parametric mode. If you go to mode, all right, and then you go over and you go down to where function is. And if you go over to parametric, we can press enter. All right. And we can say y equals, and you notice an x and a y comes up. So here we can do x squared, and actually we'll pop up with the t's like we did, minus 2t, or, and then for the y's, it was, what was it? T plus 1, like that. All right, and so when I go and graph it, there we go. Now, mine doesn't quite look the same because right here, I had it come here. But if you go to your window, you can see like where you want your t's to start at. So say if I did my t's, like I started it on my table at -2. All right, and then I ran it to when t equals 3. And I'll just do a step of 1 for t's. All right, and graph it. Oops, that looks really bad. All right, maybe I should do a step of 1. All right, maybe I should do, and I think it's jotty because of, let's do like this. There we go. Now there's the graph. It takes a little playing around with. You can also change your window as far as your X max and your Y max and all of that as well. All right, so let's go back here and let's write some more parametric equations. So let's look at number 2 right here. I want to describe the curve defined by x equals cosine t and y equals sine t. And I want to do it between t equals 0 and 2 pi. So let's go do some nice t values for that. Think of the unit circle like pi over 2, pi, 3 pi over 2, 2 pi. All right, because we know what these values are for sine and cosine. All right, we want to come up with our x and y. So here, cosine at 0 is 1. Sine at 0 is 0. All right, cosine at pi over 2 is 0. Sine at pi over 2 is 1. All right. Let's see. Cosine of pi is -1. Sine of pi is 0. All right. Cosine of 3 pi over 2 is 0. Sine of 3 pi over 2 is -1. And 2 pi, let's see, cosine of 2 pi is 1. And sine of 2 pi is 0. All right. So here we go. Let's go graph this right here. Okay. I notice it only goes out -1 and 1. So, all right. So here we go. When I look at this right here, so 1, 0. All right, 0, 1, -1, 0, 0, -1, and then back here. So I'm doing it this way. Don't forget to put your arrow so you know which direction you went with it. All right, so it's something like that. And what does that look like? It actually looks like a circle. All right, with radius 1. All right, so how do we isolate something that has cosine? Now, the problem is like here, the other one we solve for t up here, and then we put it into the other equation. We can't really do that with sine and cosine, but let's think about this. You know this trig identity, cosine squared t plus sine squared t equals 1. All right. So what do we know? So we're going to use this trig identity. All right. And if you think about cosine, cosine is x, sine is y. So this would be x squared plus y squared equals 1. And if you remember anything from math 3, when you talked about circles, you may have also talked about them in pre-cal as well. This is a circle with the center 0, 0, which this is with a radius of 1. All right, let's go look at another one. Okay. Number 3. Okay, x plus 3 plus 2 cosine t, and then y equals -1 plus 3 sine t, like that. Okay, so t equals, we'll do those nice ones again. Now be careful here. This isn't straight just cosine and sine. You got some other numbers with those. All right, whoops, and that should be an equals right there. Okay, so here cosine of 0 is 1. 1 times 2 is 2 plus 3 is going to be 5. All right, and then you would plug in 0 here. Well, that's 0, so it leaves us with -1. Here, cosine of pi over 2 is 0, so this leaves us with 3, but pi over 2 is 1. Okay, so that's going to be 3 plus -1, which is 2. All right, cosine of pi is -1. All right, so that's 3 minus 2, which is +1. All right, and then pi, that's going to be 0, leaves us with -1. 3 pi over 2, that leaves us with 0, so this is going to be a 3. This is, let's see, when I plug 3 pi over 2, that's -1, so -3 minus plus -1 is -4. 2 pi, that leaves us with 1, so 3 plus 2 is 5. And then here that's 0, so this brings us back to -1. All right, so let's go graph this. All right, I see like the max on the x is 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 1, 2, 3, 4. That might be all we need. Okay, so here we go. And again, if you're using graph paper, it's a little bit easier and you actually see like it looks better than what I'm doing on notebook paper. Okay, so 5, -1 is right here. Okay, 3, 2 is here. Okay, 1, -1 is there. Okay, 3, -4 is here. And then 5, -1 is here. So it's going around like this. And guess what? It appears that we have another circle. All right, put your arrows in to show which direction that you did it. Okay. Now mine looks like a circle. We're actually going to see later it's not actually a circle. Okay, so we know x equals 3 plus 2 cosine t and y equals -1 plus 3 sine t. Okay, so remember this. Like here, the cosine squared t plus sine squared t equals 1. Now, here's the thing. The last one was actually solved for cosine and sine. So we could just plug it into this formula. This isn't yet. Think about what we need to do. We need to subtract 3, and we would divide by 2 to give us cosine. And then the same thing here, add 1, and then we would divide by 3, and that gives us sine. So here, when I go plug it in here, now these are both squared. So what I would do is x minus 3 over 2 squared plus, all right, this is going to be y plus 1 over 3 squared equals 1. All right, when I go clean this up just a little bit, I'm going to do this. I'm actually going to square the denominator, which is 4. Same thing on this one. I'll square the denominator, which is 9, like that. If you know anything, if you recognize this, it's an ellipse. If you would have talked about ellipses, you would have talked about them quickly in, in pre-cal. All right. So although this is a circle is a type of ellipse, but it's maybe elongated in one direction or the other. All right. Now let's go look at another one. Okay, number 4. All right, x equals 2t minus 1, y equals 1 minus t. All right, so remember the ones that we did for number 1? All right, I'm just going to use those same t values right here. All right, so I think we've got the gist. You can pause it for a second and fill it in. I'm just going to go ahead and fill these in off of what I already have and just realize I'm plugging in these t values. Hold on, I got off because you know what? I did not put 0. 0, 1, 2, 3. There we go. There we go. Okay, so when I plot this point, or the points here, right, -5, 3. All right, -3, 2. All right, -1, 1. All right, 1, 0. Oops, and I did that wrong. -1, 1 would be right here. 1, 0 would be right here. Did I graph that one right? Nope. -3, 2. I got off a little bit. There we go. All right. 1, 0, 3, -1, and then 5, -2. All right. I'm going like this, and I'm going in this direction. What does it look like? It appears to be a line. Okay, so let's see if my equation comes out to be a line. Now, this one is 1. It doesn't have sine or cosine, so we are going to solve for t. All right, in one of these. It just kind of, in this one, it doesn't really matter. I'm going to solve this one because I won't get fractions. If I do this one, I believe I get fractions. So here, if I subtract 1, that's a negative t. So here, when I change all the signs, it becomes +1 and a minus y. All right, so now I can plug that in. So it's 2, and then instead of t, put 1 minus y minus 1. And if you want to clean this up, it looks like this, 2 minus 2y, all right, minus 1. So x equals 1 minus 2y. Now, anytime we've looked at equations of lines before in, say, Math 1, you always have it solved for y. So we can solve this for y. And when I do this, it would be like -1/2 x plus 1/2. And let's look at it. The slope is -1/2. This is definitely negative, and it's down 1 over 2. All right. Does it look like the y-intercept is at 1/2? And it does. All right. So this one does have, it was a line written as parametric, a set of parametric equations. All right. Let's look at number 5. All right, I'm going to write this out. All right, or actually, I'm just going to show it to you right here. Okay, if you want to copy it down, you can. It says a particle moves about in a plane so that its position at time t is greater than or equal to 0 is given by the parametric equations. Find the distance traveled from basically t equals 0 to t equals 24. And there's our parametric equation right there. Okay, so to find the distance traveled from that, what we need to do is, so we would take this, divide by 10 on each one. And so you're just left with cosine of pi over 4t and then sine of pi over 4t. All right. Okay, now this actually gives us, when we throw it into the equation, the sine squared theta plus cosine squared theta equals 1, we get this right here. X over, okay. And really, this is just because these numbers underneath here are the same, it's not an ellipse this time, it is a circle. So when these numbers are the same underneath here, it is a circle. And what I did was, when you square it, it gets 100 here. When you square it, it gets 100 here. So I multiply each side by 100. So our equation is x squared plus y squared equals 100. All right. Now, this is just an equation of a circle. So we want to know an equation of a circle. All right. What distance I go around from t equals 0 to t equals 24. All right. So the distance around a circle is called circumference here. All right. 2 pi r. All right. Okay. Now, look at what I've done here. Okay, I'm going from 0 to 24. All right, so till t equals 24. So what I did was, right here in each of these equations is pi over 4t. So pi over 4 times 24 is when you go 6 pi. Well, think about it. How much is around one circle? Think unit circle. Well, that's 2 pi. So really, I've gone around here 3 times. Okay, so since I'm going around the circle 3 times, if I just find the circumference of one of the circles, the one time, so 2 pi times, and remember this is r squared, so square root of 100 is 10, so 2 pi times 10, and then times 3, I've actually gone around 60 pi times. All right. Now, let's look at number 6. This is going to be our last one. We'll change this to 6. Okay, a particle moves about in the plane so that its position at time t is given by, all right, we've got x equals square root of 72 minus t, and we got y equals the square root of t. All right, find the length of the particle. All right, so this is the problem that we're looking at. All right. Now, there's got to be, last time they gave us from 0 to 24. This time, let's think about parameters that have to be on this. Okay, both of these have a radical on them. So let's look at, especially like this one. What can t not be? Well, it can't be negative underneath it here, but it can be 0. All right, so we can start t at 0. All right, but what number can it go to? Well, here we want to keep this value greater than or equal to 0, because if it drops to negative, you can't have a negative underneath the radical. So think about this for a second. You can say negative t greater than or equal to negative 72, t if I flip it around. Okay, so that means t is less than or equal to 72. If it goes over 72 is when I'm going to have a negative. All right, so I've got to go from 0 to 72. All right, now, unfortunately, this isn't a circle, so you can't like use circumference this time. All right, so we're going everywhere from, and if we want to draw this out, we can. Whoops. All right. And use t-values. I actually picked these t-values. You may see it in just a second. 4, 9, 25, 36, 64. Now I am going up to 72. All right, X and Y. The reason why I did that is here, square root of 0 is 0. Here, when I plug 0 in, I get square root of 72. All right, square root of 4 is 2. All right, here, this is going to be whatever the square root, and I've got these backwards, actually. Hold on. The 0 should be here, 2 should be here. This is square root of 72. All right, this is square root of, think about it, 72 minus 4. All right, that's square root of 68. All right, this is square root of 9, which is 3. All right, so square root of 72 minus 9 leaves us with 61, or nope, 63. So square root of 63. All right, square root of 25 is 5. All right, but this leaves me with square root of 47. Square root of 36 is 6. Here, when I do 72 minus 36, I get 36, and so that one's also 6. Square root of 64 is 8. This leaves me with square root of 8, and then when I plug 72 into this right here, I get 0. All right, but this is going to be square root of 72. All right, so we can graph it. All right. And think about what the square root of 72 is for a second. Okay, so here, if I do square root of 72, all right, so all right, so here we go. X is going to be somewhere in between 8 and 9. All right, and 0. This is going to be, okay, square root of 68. Okay, so that's 8.2, something like that, and 2. All right. Here, square root of 63. All right, and I'm just plotting this as 7.9. All right. All right. And it actually ends up, and so what happens is I'll do 6, 6, 1, 2, 3, 4, 5, 6. 1, 2, is right here. And then ultimately we end up with this point. And so it's going like this. All right. We want to know what is the length from here to here. All right. It appears to be a quarter circle is what it kind of looks like. All right. So here, let's think about, and let's think about this for a second. If I go back up to here, okay, and I solve for, say, t, all right. Here, if I solve for t, I get y squared equals t. Here, if I start solving for t, I get x squared equals 72 minus t. All right. And then, so that's x squared minus 72 equals negative t. And so negative 72, or no, positive 72 minus x squared equals t. We can actually set these equal to one another. Y squared equal to 72 minus x squared. All right. And if I move this over, I get x squared plus y squared equals 72. All right. So we did actually just verify this is a circle. But here, to go from here to here, it's a quarter circle. All right. And since it's a quarter circle, we're just going a quarter of their circumference. And remember, this is the radius squared. So when I take the square root, all right, the radius is the square root of 72. All right. If we want to simplify this, square root of 72, let's see, that gives me 1/2 pi. Square root of 72 is actually 6 square roots of 2. So this ultimately makes 3 pi square roots of 2 as my answer, or you can get the decimal for it. All right. So this is how to draw parametric equations. and write a parametric equation, or given parametric equations, write an equation for it. It could be a function, it could not be. And then we also found the length after we figured out things were circles, and we could use the circumference formula of a circle to help us out with that. All right, do your best doing your homework. And just if you have questions, please let your teacher know.